Now we talk about data objects and data types. Data objects are like the containers that you see here, and data types are like what goes into the container. It could be water, it could be honey, it could be juice, it could be right about anything. Okay. So just like that, data objects are the containers, and what goes into it is the data type. And suppose you want to transfer the content of one container or jar to the next one. It may or may not be possible, as it may or may not be allowed. The reason being that perhaps the first container can hold hot objects and the second container cannot hold hot objects. Okay. In which case I cannot pour boiling water from one jar to the next. It might break the second one because perhaps because of the material used, or it could be any other property. Okay. So in the same way, when you connect one data object with another, it may or may not be allowed. Okay. So that's about what a data object is and what a data type is. Coming on to Verilog, each data object will have a collection of possible values. Like we said earlier, some might allow boiling water, some might not allow boiling water. Same analogy goes here. So each data object can have a collection of possible values, and that collection of possible values is called a value set. And the data type defines this value set. What kind of data types can I have? I can have 0, I can have 1, I can have x, and I can have z. 0 is basically logic 0 or the false condition. 1 is logic 1 or the true condition. X is an unknown logic value, and z is high impedance. That is the case where you have a floating wire, a very high impedance state. So all these values are supported in Verilog. Data objects generally or by default are scalar. That means if I declare something like this, wire W1, W1 is how many bits? It is not mentioned. So by default, it is 1 bit. And 1 bit is what we call as scalar. Similarly, when you come here, wire W2 is declared to be of how many bits? 31:0. What does that mean? 31:0 means W2 is a 32-bit value. How did I get 32 bits? If I consider this to be W2, the first bit is the 0th bit, the second bit is 1th bit, third bit is 2th bit, and so on. Until how many bits do we have? The last bit, that is MSB, is 31. Okay, so 0 to 31 makes how many bits? 32 bits. In this manner, W2 is having 32 bits, in which case it is an array of elements. Each of these are elements. So it is an array of elements. It's a one-dimensional array of elements. And that is what we call as a vector in case of Verilog. Let us learn a few data objects. Net, register, parameter, integer, just a few of them. First one is nets. Nets is defined by the keyword wire. We don't have a keyword called net. We have keywords that represent a net. And in this case, it is wire. Wire is literally your physical wire that connects any two different modules. You have module M1 and module M2, and wire is what carries information out of M1 into M2. The wire by itself does not hold on to any value. It just carries the value from one point to another. That means it has no memory. It does not hold on to a value. The point here is it does not have a memory. So it is just continuously being driven by the output of M1. That is it. That is a wire. Now these are once again, like we said earlier, wire W1. In this case, W1 is a 1-bit value by default, even though it is mentioned. And by default, if I check the value of W1, it is actually Z. Okay. So the default value, unless otherwise mentioned, is Z for a net. Example is wire A. You have declared the net A for the given circuit, any given circuit. Wire B, C, you can declare it like this also. That means continuously with just separated by a comma. You can give wire B is equal to 1 tick B, which means that this 1 indicates the number of bits, okay, number of bits that B has. B indicates the type, in this case it is binary, B stands for binary, and 0 indicates the actual value of D. Okay. So net D at the time of declaration itself, it is fixed to a logic value of 0, as we see here. Please remember that let is not a keyword, but it just represents a class of data types like wired and, wired or, tri-state, tri-state and, tri-or, tri-register, etc. Registers are the second type. The keyword used here is reg. Now, registers represent data storage elements. That means it can store a 1-bit data. Suppose I have the reg C. It can hold on to a 1-bit data. That means it has some memory. It has a 1-bit memory. When you declare something as a reg, internally, either a flip-flop or a latch might be created. Flip-flop or latch. These are 1-bit memory devices. And these are effectively just a variable that can hold some value, and it does not need a driver, because once you have applied a value to this register, it will hold on to the value. Suppose you apply 0, it will hold on to that value unless it is rewritten or overwritten by the next value. Okay. The default type that is used here is X, not Z, it is X here. Example, you declare something as reg reset. So when you declare it, the reset reg can hold its value. After 100 units, as you see here, after 100 units, the value of reset might be changed. Initially it was 1, and after that it has changed to 150. What happens here? The reset value has been held at 1 for the 100 units of time. The last one is parameter. Parameter, it defines a constant. Only integers and not real parameters. We can use only integers in the case of parameters. Effectively, it is just a constant. Suppose we take the example of small here. The value of small is 1. This 1 is an integer. We are not allowed to use real numbers. Okay. So that is for constants, or the keyword is parameter itself. The last one that we are going to see here is integers. Integers are just like we have used in C programming. It can be used to declare general purpose variables, and it has some numerical value. It does not have a direct hardware intent, and at the time of declaration, as you see here, integer n, no range is specified. No range is specified at the declaration time. Now, integers can be positive or negative. N can be either positive or negative. So when you have signed numbers, we have options to represent signed numbers. You have options like sign magnitude, 1's complement, 2's complement form. And the form that is used in this case is 2's complement. So please note that when the result is negative, you will be given a value that is in 2's complement form. The next topic is operators. Operators are mainly 3 types: unary, binary, and ternary. The name itself will tell you this is 1, this is 2, and this is 3. This 1, 2, 3 actually tells us the number of operands that it handles. What are operands? The inputs that are given. What are operators? Operator is the defining operation. For example, if I have A plus B, A and B are the inputs, so they are called operands. Plus is the operation that is done, therefore plus is the operator. Okay. Therefore, in case of unary operators, you need only one operand. B is the operand there, and therefore A is equal to tilde B means it is a NOT operation performed on the operand B, and that is stored in the variable A. Binary operators require 2 operands, in this case B and C, and the operator is ampersand in this case. So it needs 2 operands, and after the operation the value is stored in A once again. Ternary operators require 3 operands, B, C, and D. In this case, you have A is equal to B question mark, C, colon, D. Here, what is done is a condition is checked. If it is true, the first value is assigned. If it is not true, the second value is assigned. To whom? To A. So that is ternary operator. It requires 3 operators. Okay. So that is operators used in Verilog. These are the types of operators, and most of the operators can be classified under these. That's all for now. Basics of Verilog. We'll see you in the next class. Thank you.